Good day, everyone. We are Group 16, and our group topic is Smart Public Transport System. My name is Oljashan, and they are my group mates, Mei, Tommy, and Lao Junxiang. Recall in the past is suffering to take public transport as they are not fully utilizing technology, having insufficient public transport during peak hour, and has high frequency of malfunctions. Today, we have many forms of public transport utilizing advanced technology, but still, they are packed during peak hours and have service disruption sometimes. If lesser people uses public transport, it will lead to air pollution ultimately. Now I would like to pass to Junxiang to further present.
Hi, I'm Lao Junxiang. Now I will be presenting about the problem statement of our project. The first problem would be the current public transport system has inefficient routing and scheduling, which often result in bus delay. The buses travel on fixed route without taking into account the situation during peak hour, resulting in poor user experience. Secondly, the current public transport system has poor maintenance and asset management, in which we can usually see the public transport breakdown during the operating hour. And lastly, the rising pollution index in Malaysia due to vehicles overcrowding. The increased vehicles using on the road lead to rising of harmful gases released into the air and causes air pollution in Malaysia. And next, I will be presenting the objective of our project. The first one would be to improve the efficiency of the current public transport system by integrating the public transport with advanced I/O device to dynamically modifying vehicles allocation to minimize delays. Secondly, is to minimize the safety risk of the passenger by prioritize the maintenance tasks on those infrastructure required by using a sensor. And lastly would be to enhance the passenger experience while using the public transport, since the traffic condition can be improved due to enhancement of public transport. Next, I will pass to the next presenter to present on the part. Thank you.
So, hi everyone, my name is Mei, and I'm going to explain about our architectural diagram. So firstly, we will get the data from the devices such as like the infrared camera and also the sensors. And for the camera, we will pass in the images from the IoT core to the S3 bucket. And then afterwards, the Lambda will be used to get data from the S3 bucket and analyze it in the recognition and lastly pass it into the DynamoDB. Same as the sensors, it will directly goes into the IoT core and directly get into the DynamoDB. And for the data in the DynamoDB, it will be mainly for three usage. Firstly, we will use it in the Amazon SNS to give the urgent informations. And for the Amazon antenna will be used to analyze the data and afterwards will be sent into the Amazon Quick site to get the trends of the data. And lastly, Amazon API will be used to pass the maintenance data to the mobile application. So now I will pass it to the next presenter.
Thank you, Mei. Now I will present on the AWS IoT core and DynamoDB. So first, we need to create the IoT device by navigating to the Things tab and click on Create Things. Next, we could choose from create single thing or create many things. In this case, we create single thing and input the thing name and click on Next. Next, we need to attach policies to certificate. We will press on Create Policy and input the policy name, set the policy effect to allow, action and resource to all and click on Create. We will then select the policy we create just now and press Create Thing. We will need to download all the device certificate and keys to be used later on. This is a list of IoT that we have created. And this is the list of policies that we have created. We then will go to MQTT test client to get the client ID and endpoint, which will be used later on. To simulate the sensor data using the JavaScript, we first create the MQTT by input the private key, certificate, and CA1 path, as well as the client ID and endpoint we get from the MQTT test client just now. This is the example function to read the speed of the vehicle. In this code, we then connect to the MQTT and subscribe to the topic speed. The data will be published to the topic every 5 seconds. To view the MQTT, we can subscribe to the topic by input the topic filter, choose the quality of service and MQTT payload display format. To publish the data to DynamoDB, we first need to create the table by input the table name, partition key, and sort key, which is optional. The table uses the default setting, and we will click on Create Table. Next, we navigate to Rules in IoT Core and click on Create Rules. We will need to input the rule name and rule description, which is optional, and click Next. Afterward, we can select the SQL version, which is 2016, March 23, and input the SQL statement to retrieve the data from the MQTT. In the action, we will choose the DynamoDB version 2 and choose the table that we have created, and in this case is the vehicle speed. We will then create a new row for DynamoDB. In the row, we click on Attach Policies and mark on the Amazon DynamoDB read-only access and click on Add Permission. After finish reviewing and create, when the data is sent to the MQTT, the data will be forwarded into the DynamoDB table. This is the example of the data generated. That's all for my part. Now I will pass the slide to Mei Mei to continue on her part.
Thank you. And so I'm going to continue with Amazon S3 and also Amazon Recognition. So firstly, if you want to get the image from the IoT core, you have to create the S3 bucket by clicking the create bucket. And then afterwards, you have to do some configuration, which is putting in the global name for the S3 bucket and such. And we have to click the create. And when we successfully create the S3 bucket, we were able to see that the data will be successfully get into from IoT core into the S3 bucket. And here's some of the data that we successfully putting in. Afterwards, you have to create the Lambda to connect the S3 bucket with the recognition and also the DynamoDB. So we create the function. And after that, we have to do some configuration such as putting in the function name and also the language we are using. And the most importantly, we have to put in the IAM role, which is giving the permission for Lambda to access the S3 bucket, recognition, and also the DynamoDB. Afterwards, we have to create the add trigger, which is we have to connect the Lambda with the S3 bucket, the specific S3 bucket that we have created. And afterwards, we have to add in our coding into the Lambda, and which it will help to connect S3 buckets and then analyze it in the recognition, and lastly, sending the data that we have processed into the DynamoDB. So when this is successfully been done, we'll get a response of 200, and we were able to see the items stored inside the DynamoDB. So that's all from me, and I will pass it to the next presenter.
Thank you, Mei Mei. I'm responsible for the Athena and QuickSight in this project. Firstly, to use Athena, we need to create two S3 buckets to store the data spill and query data. Then we create the data source from DynamoDB. Lambda function is created so that DynamoDB can communicate with Athena. After that, we run the query to query the data from DynamoDB. To use the QuickSight, we first need to create a QuickSight account. Then we grant AWS Lambda role permission for QuickSight so that we can connect to our database. After granting the permission, we're now able to load the datasets for Athena into QuickSight. With all the dataset loaded, we can start to do the analysis now. There are three sheets in our analysis, namely public transport, air pollution, and route optimization. In our analysis, we utilize the filter feature. For example, the filter list, top filter, and date range filter. Besides, we also connect the filter with parameters. For instance, we can filter the vehicle ID using the vehicle ID control or using start date and end date parameter to control the data. Next, we utilize the calculated field to show some useful information on the analysis. For instance, we calculate the date difference. Then in the analysis, we also did some visual formatting to make the dashboard look attractive to users. After doing our analysis, it's now to deploy it as dashboard. The first sheet is public transport sheet. In the pie chart and table, we can see all the public transport details. At the bottom, we use a KPI chart and bar chart to illustrate the average maintenance frequency and operation hours of respective type of public transport. Next, in the individual public transport section, we use the vehicle ID control and start date and date parameter to control all the graph below. Once the parameter changes, the graph will change accordingly. By doing so, it helps the user to check vehicle condition easily. These are all the information related to the individual public transport. Besides, to ensure all the driver drive safely, we also introduce the bus speeding detection. Inside the map, each point represents speeding of one bus at the location. Moving forward, the second sheet is air pollution sheet, where we can observe today's pollution AQI of all cities. In addition, the line graph shows pollution AQI of the selected city over past selected days. By observing the graph here, the users are able to use the data to predict the upcoming pollution AQI. Lastly, the route optimization sheet contains the information regarding the bus stop. From the chart here, the user are able to see the amount of people uses the respective buses in the bus stop so that they can adjust the frequency of buses to the bus stop accordingly. That's all for my part, and I will pass to the next presenter.
So now I will be presenting about the Amazon simple notification service and integrate with the AWS Lambda. Firstly, we have to grant the IAM permission to the SNS service, which include the Amazon SNS full access, AWS Lambda execute, AWS Lambda invocation, DynamoDB, and lastly, the Amazon AppStream full access. After we have granted the permission, we have to create a topic for the SNS and name it. Create a standard topic and name the topic and click on the create button to create the topic. And next step, after we have created the topic, we have to create the subscription and the protocol we are using and the subscriber email address here and click on the create subscription. And after the subscription is created, we have to go to the subscriber email and confirm on the subscription. And next, after the topic and subscription is successfully done, we have to develop the Lambda code to invoke the SNS service. This is the Lambda code is basically to detect the abnormal value from the vehicles, and it will invoke the SNS when abnormal value is detected from the DynamoDB. So after that, we have to add the DynamoDB trigger to the SNS by clicking the add trigger here. And after the trigger has been set, whenever there is a record with abnormal value is inserted into the DynamoDB, the SNS will be triggered and send an email to the recipient. So next, I will be presenting about the Amazon API. First, we have to write the Lambda code to convert the record in the DynamoDB to JSON format. And here is the table name in the DynamoDB. And here is the content. After that, we have to create a REST API by clicking the build button and name the API name and click on the create API button. After that, we have to create a get method and integrate it with the Lambda function by selecting the Lambda function and choose the Lambda we created just now. And after that, we can deploy the API by clicking the deploy API button. And we can copy this URL and put inside the Android Studio to fetch the data. This is a sample in the Android Studio by pasting the URL inside it, and it can successfully fetch the data from the DynamoDB to our mobile application. Yeah, that's all from me. Thank you.